Hello and welcome. I'm Ben from Digi Technical Support. In this video I'm going to show you how to configure your Digi accelerated Linux router to accept PPP dial-in calls via the DB9 RS232 serial connection. For this demo I'm using the IX20 router with firmware version 22.5.50.62. The scenario in this example would be if you have a serial PLC or some sort of metering device that is able to make an outbound connection via a PSTN modem. Instead of connecting that device to a PSTN modem, you could connect it to an IX20 or other DAL router, which will emulate the PSTN modem and accept the PPP call. When the PPP connection is up, you can use port forwarding on the DAL router to be able to access the web interface on the connected device. Or alternatively, you'll be able to send command and control data to the PLC or meter for automation. I have a WR31 router connected that supports PPP dial-out connections on its DB9 RS232 serial interface. The connected serial device should be configured to keep the PPP connection active all the time. The IX20 serial interface is a DTE, and the WR31 serial interface is a DCE, so a straight-through serial cable has been used. If the connected device was also a DTE, you would need to use a crossover or null modem serial cable. In the web interface, navigate to System, Device Configuration, then Serial, Port 1. Change the serial mode to PPP dial-in. Give it a friendly or descriptive name. Set the baud rate and flow control to match the connected device. I know the WR31 is using 115200 and no flow control. It would be normal to set a high idle timer or disable it. This will allow the connected device to control the PPP session. Expand the PPP dial-in section. Add the local IP address. This is the IP address that is assigned to the IX20 side of the PPP session. The remote IP address is going to be assigned to the device connected to the serial port when it brings up a PPP session. Set the authentication type to match the settings used on the connected device. For this demo, I'll be using PAP. The username and password is what the WR31 is going to send over to authenticate. This must match what is being sent. Set the interface metric to 200. This will ensure that when the PPP interface comes up, only traffic destined for the connected device will be routed via this PPP interface. The firewall zone should be set to internal. Expand the custom PPP section. Enable the extra settings, but leave override switched off. You can now add extra configuration commands into the box below. PPP is a negotiated connection. This means the local and remote devices need to agree on various parameters before the PPP session will come up. If you get the settings wrong, there's a good chance that the PPP session will not be established. To get a working PPP session, you will need to know in advance what the PPP settings are on the connected device. For example, I know that the WR31 I have does not support compression type CCP. The PPP session must be IPv4 only. The MTU used will be 1400 bytes, and I want debug information to be sent to the messages file for easier debugging if anything goes wrong. When you add the extra commands, they all go on one line with a space between them. There is no need to wrap the commands in quotes or comma separate them. Other options can be set. You will need to refer to the Linux PPPD manual page via a Google search to see the options. Extra scripts can be executed before PPPD is started, but this is not required for this demo. This is the IX20 configuration complete, so we can apply these settings. I'll switch to the WR31 and test the PPP connection. You can see in the interface status that the PPP interface is now up. The IP address assigned to the WR31 is 192.168.44.2. And I can also ping the IX20 on its IP address, 192.168.44.1. To check the status in the IX20, we go to Status, Serial, and this shows that the interface is connected with the WR31 and the IP address of the remote device, 192.168.44.2. The final task is to make use of this PPP connection. I'm going to set up a port forwarding rule to redirect telnet to the WR31. Go into Firewall, Port Forwarding, and add a port forward rule. Give it a name. Pick the WAN interface. In this case it is ETH1 for the outside interface. Pick the IP version and protocol, and the incoming port number. For telnet, that will be 23. And we're going to redirect the traffic to 192.168.44.2, which is the IP address that's assigned to the WR31. I don't need to add a destination port because it is automatically implied that if you leave this blank, the same destination port number will be used. I am going to restrict this though to the external zone. That means that only traffic entering this router via its external zone interfaces will be able to take advantage of the port forwarding rule. And now I'm going to telnet to the IP address of the IX20. I've got a login prompt, and now I'm logged in. Type a command into the WR31, and you can see here it's responded to say that it's a WR31 router. Although I'm connecting to 172.168.0.20. This proves that the port forwarding connection has worked. That's the end of this demo. I hope you found this useful, and thank you for watching.